All right, ladies and gentlemen, this is the solutions video for the geometric polynomial division problems. Let's get started with number 1 from the practice assessment. Taylor, Allie, JC, Lexi, Sheridan, and Randy are designing a new softball pitcher's plate with a total area defined by a of x equals 10x squared minus 28x minus 6 square inches. If the width of the plate is defined by w of x equals x minus 3 inches, which function correctly defines its length? Okay, it does help to visualize these problems, so we'll just draw what looks like a pitcher's plate. It'd be kind of like an elongated rectangle. And we're actually given a piece of information here. We're told that the total area, that would be this filled in region here, of the pitcher's plate is defined by this function a of x. So we can say, let me zoom in here a little bit. We can say that a of x equals 10x squared minus 28x minus 6. There's a handy little reference triangle that we can use to remember our formulas for area. And here it is here. The A for area goes here, the L for length goes here, and the W for width goes here. And you come up with these three formulas. Area equals length times width. Length equals area divided by width. And width equals area divided by length. So we want to use the one for length. I'm going to use this formula here. And let's see if we were given the width, because we have the area, and yes, we're given the width right here. So down here for this short side, this little short side right here, this is going to be w of x, and that's the width. Okay, so that function was given by x minus 3. What we don't know is the length. Okay, so we don't know L of x, and that's what we need to find. So here's how we do that problem. We say 10x squared minus 28x minus 6 divided by, that's the area. We're going to divide the area by the width, which is x minus 3. Okay, first step, divide the first term of the dividend by the first term of the divisor. So over in side work here, we'll divide 10x squared by x. Okay, so that's 10x to the 2 minus 1, applying the quotient rule, equals 10x. This is the first term of your quotient, and that gets written above the matching term of the dividend. So you'd put it right here, 10x. Now you multiply the first term of the quotient by the entire divisor in side work. So that's 10x, open parentheses, x minus 3, close parentheses. We'll use distribution to get rid of these parentheses. 10x times x equals 10x squared. 10x times negative 3 is negative 30x. This gets written right beneath its matching terms of the dividend. So that will be written right there underneath its matching terms. So we'll write 10x squared minus 30x. Now we draw a line, and we change both of our signs. So this 10x becomes negative 10x, this negative 30x becomes positive. These first terms cancel, and this next set of terms adds together to give us 2x. Next step is to bring down the next term of our dividend, minus 6. And then we start the process back over. Divide this term of the dividend by the first term of the divisor. So that's 2x divided by x. That equals 2x to the 1 minus 1, which equals 2x to the 0. X to the 0 is 1, so that equals 2 times 1, which is just 2. That 2 is a quotient term, gets written up here, plus 2. And now we multiply this new term of the quotient by the entire divisor. Zoom out a little bit here. So we'll multiply 2, open parentheses, x minus 3. Distribution. 2 times x is 2x. 2 times negative 3 is negative 6. That gets written underneath its matching term of the dividend, which would be right there. Okay, so we'll write 2x minus 6, and then we draw a line, and we change both of our signs. They both cancel. There's no remainder. This is the quotient, 10x plus 2, and that is the length. So zooming in now, we have found our missing term. So that L of x equals 10x plus 2. And the answer choice that corresponds to that is A, 10x plus 2. Moving on. Number 2, Leo, Tyler, Taylor, Yeye, Isidro, and Michael are building a football field. Okay, the length of the field is defined by L of x equals 5x plus 9 meters. If the total surface area of the field is defined by A of x equals 5x squared minus 16x minus 45 square meters, which functions correctly defines the field's width? Okay, so a little bit of grammar errors here. So that should say which function correctly defines the field's width. All right, so first let's draw the picture and label what we're given. In all these problems, we're going to be given the area. So we'll go with a green here for turf. So this is the football field, and we're given the area of this field. The area of the football field is given by this function. Area is given by A of x equals 5x squared minus 16x minus 45. What else are we given? We're given the length. Okay, so that's the long side here. So the length is given by L of x equals 5x plus 9. And the thing that we'd like to find is the width. That's this shorter side here. So we want to find the width, and we don't know it, but it's going to be W of x equals something. All right, that's what we don't know. And so the area formula that we'll use to find it is width equals area divided by length. In other words, W of x equals A of x divided by L of x. So in division notation, in long division notation, we'll put in here 5x squared minus 16x minus 45. Ruler comes out to do the long division bar, divided by the length, which is 5x plus 9. Okay, so this is our new work area here. Now we take the first term of the dividend and divide by the first term of the divisor. So 5x squared divided by 5x over in side work. I'll start it up here. 5x squared divided by 5x. First, we reduce the numericals down to ones, since 5 over 5 reduces to 1 over 1. And that equals x to the 2 minus 1, remembering that there's a 1 in the exponent in the denominator, and that's x to the 1, or x. And that's our first quotient term. That gets written above its matching dividend term. So we write the x there, then multiply the first term of the quotient by the entire divisor. So that's x times 5x plus 9. Distribute multiply. 5x times x is 5x squared. 9 times x is 9x. And so that's the first term that we put underneath the dividend, matching up the terms. Just like this. And now we take our ruler and we draw a line, change both signs. These first terms always cancel, and these second terms never cancel. Negative 16x minus 9x is negative 25x. And we will bring down the next term. Bring down that negative 45. Start all over. Divide this term of the dividend by this term of the divisor. So we divide negative 25x by 5x. Reducing the numerical part gives me negative 5 in the numerator and 1 in the denominator. So I have negative 5x to the 1 minus 1 gives, zooming out a little bit, negative 5x to the 0. The 0 exponent rule tells me x to the 0 is 1, so it's negative 5 times 1, which is just negative 5. That is a quotient term. That gets written up here, minus 5. Then I multiply negative 5 times the entire divisor. So I have negative 5, open parentheses, 5x plus 9. And we distribute. Negative 5 times 5x equals negative 25x plus, well, negative 5 times 9 is negative 45. So it's just minus 45. And that gets written here. Negative 25x minus 45. And then we draw a line. And we change both of our signs. And both these terms cancel with no remainder. So we found our quotient, which is x minus 5, and that is the width. W of x equals x minus 5. Okay. Skipping number 3. Number 3 had a typo in it, so the answer to choose is C. L of x equals 7x plus 8. But we'll skip it since it had a typo. On to number 4. Ashayla, Shauna, Rodnisha, and Jaden are taking measurements for a new maple hardwood basketball court whose area is defined by A of x equals 3x squared plus 14x plus 16 square meters. If the width of the court is defined by W of x equals x plus 2 meters, which function correctly defines the length? Again, we start with a picture. Looking from above, a basketball court looks a lot like a tennis court, looks a lot like a football field, looks a lot like a soccer field, just a rectangle. And we'll choose a color here to shade. So we're given the area of this basketball court. And the area, A of x, is equal to 3x squared plus 14x plus 16. So I'll write that here, 3x squared plus 14x plus 16. What else were we given? Looks like we were given the width of the court. So that would be this length right here, or this distance right here, the width. w of x, and that equals x plus 2. So the thing that we're missing in this problem is the length. So we need to find out what L of x equals. The area formula we'll use is L of x length equals A of x area divided by W of x width. So let's come down here and write out 3x squared plus 14x plus 16. Get our ruler going. Division bar. The divisor is the width, which is x plus 2. And now we get started. So zooming in on this part of the problem, we divide the first term of the dividend by the first term of the divisor. So that's 3x squared divided by x. That equals 3x to the 2 minus 1, remembering there's a 1 in the exponent position of the denominator variable. And that's 3x to the 1, which is just 3x. That is a quotient term. And so that gets written up here above its matching term of the dividend. Then we multiply the quotient term by the entire divisor. You always multiply the quotient term by the entire divisor. So that gives us 3 of x multiplied by x plus 2, this binomial here. And that is distribute multiply. 3x times x is 3x squared. Plus 3x times 2 is 6x. This gets written underneath here, 3x squared plus 6x. And then we draw a line, and we change both of our signs. So this cancels, as it always shall, and we have 14x minus 6, which is positive 8x. We bring down the next term, plus 16. Start all over. Divide this term of the dividend by the first term of the divisor. So 8x divided by x. Okay. There's nothing to simplify numerically. We remember there's ones in the exponent positions of these variables. And apply the quotient rule to say 8x to the 1 minus 1. Which equals 8x to the 0. Apply the 0 exponent rule to say x to the 0 equals 1 to give 8 times 1, which equals 8. And that is a quotient term, which gets written up here, plus 8. Now we multiply this new term of the quotient by the entire divisor. And that gives 8 times x plus 2, this binomial right here. And we're going to distribute multiply the 8. 8 times x equals 8x. 8 times 2 equals 16. So we write 8x plus 16. And then we draw a line, and we change both of our signs. Just like this. They both cancel. There's no remainder. This is our quotient. And so what we found is that L of x equals 3x plus 8. Okay, moving on to number 5. Austin, Morgan, Murph, Matthew, Ryder, and Tyler lined up all the bases on a baseball field to form a long rectangle and measure them to find a total area defined by A of x equals 4x squared minus 36x plus 56 square inches. If the length of all the lined up bags is defined by L of x equals 4x minus 8 inches, which function correctly defines the width? Okay, so let's look at these. This is like the three bases. If you lined them up, they'd form kind of a long rectangle here. And we're given the area and we're given the length. Okay, so let's pick a color for our baseball activity here. I guess I'll go with I guess I'll go with blue. Okay, so here's our three bases lined up together to form a large rectangle. And that area function, area is given by a of x equals 4x squared minus 36x plus 56. The other thing we're given is the length, this long side here on the bottom. And length is given by L of x equals 4x minus 8 inches. Okay, so the thing we don't know is the short side. We don't know the width. The width is given by w of x, but we don't know what it is. So we have to use the area function w of x, which is width, is equal to a of x, which is area, divided by L of x, which is the length. So substituting in those values into our long division format, we have 4x squared minus 36x plus 56. Take the ruler, put in that long division symbol, and then write the divisor, which is 4x minus 8. 4x minus 8. Now that we're here, we divide the first term of the dividend by the first term of the divisor, which is 4x squared divided by 4x. Simplifying the numerical part of this fraction gives 1x squared over 1x, so that equals x squared over x. Remember, there's a 1 in the exponent section of the denominator variable, and we apply the quotient rule to say x to the 2 minus 1. Remember, the quotient rule says that when your bases are the same, you subtract the exponents to divide. 2 minus 1 is 1, so that gives us x to the first power, which is just x. This is a quotient term, and it's written above its matching dividend term. Now we multiply that quotient term by the entire divisor. So that's x multiplied by this binomial 4x minus 8. We will multiply the x, and that's equal to 4x squared. And then x times negative 8 is negative 8x. This term gets written under its matching component in the dividend, 4x squared minus 8x. And then we draw a line, and we change both signs. These first terms always cancel. And now negative 36 plus 8 is negative 28x. Bring down the next term of the dividend, plus 56. And now start the whole recipe over. Divide this term, this new term of the dividend, negative 28x, by the first term of the divisor, 4x. So we have negative 28x divided by 4x. Reducing negative 28 and 4 gives negative 7 over 1. Remember, there's exponents with these x's. They're both 1. So we're going to now rewrite everything out. Negative 7x to the first over x to the first. Apply the quotient rule. Bases are the same. Subtract the exponents. That gives negative 7x to the 1 minus 1, which is negative 7, x to the 0. X to the 0 equals 1, so it's negative 7 times 1, which is just negative 7. That is a quotient term, the negative 7. So the negative 7 gets written up here, and then we multiply the negative 7 by the entire divisor. So you've got negative 7, open parentheses, 4x minus 8, close parentheses. Distribute that negative 7. So that's equal to negative 28x plus 56. That gets written under here, negative 28x plus 56. Draw a line. Change both signs. This becomes positive, this becomes negative. They both cancel. There's no remainder, giving x minus 7 as the quotient to this division problem. And that is the width. X minus 7 is the width. Okay. Moving on to the mastery assessment. Number 1, Alyssa, Emma, Ethan, Alex, and Madison are designing a new black box theater stage with the total area defined by a of x equals 4x squared minus 14x minus 8 square feet. If the width of the stage is defined by w of x equals x minus 4 feet, which function correctly defines its length? Once again, we draw a shape. This is a black box theater stage, just another way of saying a rectangle. And here we'll do something fun. We'll go ahead and shade this in black. And we'll use a white ink color to write things inside of it. So we are given the area. The area function a of x equals 4x squared minus 14x minus 8. All right, what else are we given? We are given that the width is x minus 4. So this shorter side here, the width, w of x, equals x minus 4. So in order to find the missing side, which is the length side, L of x, we need to use this area formula that says L of x for length is equal to A of x for area divided by W of x for width. Substituting in values to our long division notation, we got 4x squared minus 14x minus 8 divided by x minus 4 for width. And so we start out here, we'll use gray. We divide the first term of the dividend by the first term of the divisor. So that gives 4x squared over x. There's nothing to reduce numerically, so we just apply the quotient rule. Remember, there's an exponent of 1 in the denominator variable. The quotient rule says when the bases are the same, you subtract the exponents. So it's 4x to the 2 minus 1, which is 4x to the first, which is just 4x. And that is a quotient term. So we'll write 4x above its matching component in the dividend. And we'll multiply 4x times the entire divisor. First term of quotient by the entire divisor. So we have 4x, open parentheses, x minus 4. And we do distributive property right here. And that equals 4x squared minus 16x. What I'm doing is 4x times negative 4. 4 times negative 4 is negative 16. And then the x comes along for the ride. So this term, 4x squared minus 16x, gets written underneath its matching terms in the dividend. And now we're on to draw a line. Change both signs. The first terms cancel. Negative 14x plus 16x gives positive 2x, and we bring down the next dividend term, which is negative 8. Don't forget to bring down the sign with the term. And now we divide the first term of the dividend by the first term of the divisor. And that gives 2x over x. Remember that there are 1s in these exponent sections. So we have 2x to the 1 minus 1, which equals 2x to the 0. X to the 0 is 1, so that's 2 times 1, which is just 2. Okay, so the 2 is a quotient term, gets written up here, plus 2. And now we multiply that new quotient term by the entire divisor, 2 times x minus 4. So that's 2 open parentheses, x minus 4 close parentheses. We do distribution. 2 times x equals 2x. 2 times negative 4 is negative 8. And so we write 2x minus 8. And finally, we draw a line. And we change both signs. These cancel, there's no remainder. This is the quotient, 4x plus 2, and that is the length, 4x plus 2. All right, moving on. I guess I better circle that one. 4x plus 2 would be this one. Number 2, Jasmine, Chloe, Samantha, Jasmine, and Jimena are installing a rectangular dance floor in their brand new Pantherette's practice room with a length defined by L of x equals 9x minus 8 feet. If the total floor area is defined by A of x equals 9x squared minus 98x plus 80 square feet, which functions correctly define the floor's width? All right, so once again, we draw a picture. We've got our dance floor here, aka any rectangle, and the Pantherettes will get, let's do a pink. So here's their dance floor. And so the area is defined by the function A of x equals 9x squared minus 98x plus 80. And what else are we given? We're given the length. We're given that L of x for length equals 9x minus 8. 9x minus 8. And so the thing we're looking for in this problem is actually the width. So we'd like to know what the width of the dance floor is, and that's going to be given by W of x, which equals something. So the area formula we need to use to find the width is W of x for width equals A of x for area divided by L of x for length. Substituting into our notation that we use for polynomial long division is 9x squared minus 98x plus 80. We'll draw a division bar here. And then we'll put the length in the divisor section. So that's 9x minus 8. So we divide the first term of the dividend by the first term of the divisor. And over here in SideWorks, that's 9x squared divided by 9x. Numerical simplification of this fraction gives 1 over 1. And so now we have x squared over x. Remembering there's a 1 in the exponent section of the variable in the denominator, and applying the quotient rule, which says that when the bases are the same, we subtract the exponents to divide, we have x to the 2 minus 1, which is x to the 1, which is just x. And this is a quotient term, so we'll write that quotient term x above its matching term in the dividend, and then multiply the first term of the quotient by the entire divisor, which gives x, open parentheses, 9x minus 8, close parentheses. Apply distributive property, and that equals x times 9x is 9x squared. X times negative 8 is negative 8x. So we're going to write negative 8x, or 9x squared, minus 8x under its matching component in the dividend section. And then we're going to draw a line and change both signs. These terms cancel. The second set doesn't cancel. Negative 98x plus 8x gives negative 90x. And now we bring down the next term of the dividend, and that's plus 80. And we repeat the process all over, dividing the first term of the remaining part of the dividend, negative 90x, by the first term of the divisor, 9x. And so we have negative 90x divided by 9x. Simplifying the numerical part of the fraction, we get negative 10 over 1. And so this equals negative 10x over x. Recalling that when x's are by themselves, they do have exponents of 1. And applying the quotient rule that says when you have bases that are the same, you subtract the exponents to divide. You have negative 10x to the 1 minus 1, which equals negative 10x to the power of 0. Recalling the 0 exponent rule says any variable raised to the power of 0 is 1. So we actually have negative 10 times 1, which is just equal to negative 10. This is a quotient term, so we write negative 10. Now we multiply the new term of the quotient by the entire divisor, and so that gives negative 10, open parentheses, 9x minus 8, close parentheses, and we'll multiply the negative 10 through the binomial in the parentheses. Negative 10 times 90x is negative 90x. Negative 10 times negative 8 is positive 80. So we write that underneath its matching term of the dividend. Negative 90x plus 80. And now we draw a line. And we change both of our signs. They both cancel. No remainder. So here's your quotient. This is the width. W of x equals x minus 10. And we're ready to move on to number 3. Dustin, Justin, Rolando, Michaela, Tyler, and Candace are building a new travel trailer for their band trips. The surface area of the trailer bed is defined by A of x equals 5x squared minus 34x plus 24 square meters. If the width of the trailer is defined by W of x equals x minus 6 meters, which function correctly defines its length? So we'll draw a picture. Here's a travel trailer, kind of an elongated rectangle. And let's give band, so give them the blue here. So this is the surface area of the trailer bed inside the trailer. And we'll switch to white, and we'll write out A of x for area equals 5x squared minus 34x plus 24. Fair enough. And then what else do they give us? Looks like they give us the width. So this little piece here, W of x equals x minus 6. So what we're trying to find in this problem is the length. Okay, so the length is equal to L of x, which we don't know, and that's what we're going to find. The area formula that we'll use is L of x equals A of x divided by W of x. So that's length equals area divided by width. Substituting values into our long division formula for polynomials, we have 5x squared minus 34x plus 24. And we'll put in that long division bar. And we'll divide by x minus 6. So we'll begin here by dividing the first term of the dividend by the first term of the divisor. And that's 5x squared divided by x. There's nothing to simplify numerically. Just remember there's a 1 in the exponent section and apply the quotient rule. Quotient rule says that when the bases are the same, you subtract the exponents to divide. So that's 5x to the 2 minus 1, which is 5x to the 1, which is just 5x. This is a quotient term, so we write it above its matching term of the dividend. 5x goes right here, and we multiply the first term of the quotient by the entire divisor. In side work, we have 5x, open parentheses, x minus 6, close parentheses. Apply the distributive property. 5x times x is 5x squared. 5x times negative 6 is negative 30x, because 5 times negative 6 is negative 30, and the x comes along for the ride. So we write that term there, 5x squared minus 30x. And then we don't forget, we have to draw a line, change both of our signs. This becomes negative, this becomes positive, this term cancels, this term doesn't. Negative 34x plus 30x equals negative 4x. Bring down the next term of the dividend, which is plus 24, and start the process all over. Negative 4x divided by x. That's the first term of the remaining part of the dividend divided by the first term of the divisor. In side work we have negative 4x over x. There's nothing to simplify numerically, so we just apply the quotient rule. Remember, those two variables have 1 in their exponent section, and the quotient rule says that when the bases are the same, which they are, we subtract the exponents to divide. So that's negative 4x to the 1 minus 1 equals negative 4x to the 0. Zero exponent rule says any variable or base raised to the power of 0 is 1. So negative 4 times x to the 0 power is equal to negative 4 times 1, which is just equal to negative 4. Negative 4 is a quotient term, so we write it above its matching term of the dividend, and we multiply it by the entire divisor. So in side work we have negative 4, open parentheses, x minus 6, close parentheses. Distribute multiply. Negative 4 times x is negative 4x. Negative 4 times negative 6 is positive 24. And we write that beneath its matching term of the dividend, negative 4x plus 24. Draw a line. Change both signs. This becomes positive, this becomes negative, and they both cancel, leaving 0 as a remainder. So we have our quotient, 5x minus 4, as the length, 5x minus 4b. Moving on to number 4. Royana, Jimmy, Jaden, Caitlin, and Molly are designing rectangular banners to wave while they cheer. Each banner's area is defined by a of x equals 6x squared minus 23x minus 4 square centimeters. If the length of each banner is defined by L of x equals 6x plus 1 centimeters, which function correctly defines its width? So here we are. We have yet another rectangular shape, something like this. This will be the banner that they're going to wave. And let's give cheer the panther orange. So here's the area that we are given. And area is defined by the function a of x equal to 6x squared minus 23x minus 4. What else are we given? Looks like we're given the length. Okay, so the length of this banner is given by function L of x equal to 6x plus 1. And so the thing that we're missing is the width, w of x, and we don't know what it is. So we're going to use the area function, or rather the area formula, w of x for width equals a of x for area divided by L of x for length. Substituting into our polynomial long division form, we have 6x squared minus 23x minus 4. Let's use a ruler to write that long division symbol. And we'll divide by the length as the divisor, 6x plus 1. So we will choose here, let's get a lighter color of orange. We're going to divide the first term of the dividend by the first term of the divisor. So that's 6x squared divided by 6x. 6x squared divided by 6x. Reducing numerically, 6 over 6 reduces to 1 over 1. Remember, there's a 1 in the exponent of the denominator. And so we have x to the 2 over x to the 1. Apply the quotient rule that says when the bases are the same, you subtract the exponents to divide. And you have x to the 2 minus 1, which equals x to the 1, which reduces and simplifies to x. The x is written above its matching term of the dividend and multiplied by the entire divisor. So in side work we have x, open parentheses, 6x plus 1, close parentheses. Distribute, multiply that x through both terms of the binomial. And you have 6x squared plus x. That gets written here underneath its matching terms of the dividend, 6x squared plus x. And I'll just put a 1 in there as a placeholder so we don't get confused. Draw a line, change both signs. These first terms cancel out, the second terms don't. Negative 23x minus 1 gives negative 24x. Bring down the next term, the dividend, with its sign. So we bring down a negative 4, and we start the process all back over. Divide the first term of the dividend by the first term of the divisor. So we divide negative 24x by 6x. Negative 24x over 6x. We can reduce the numerical part of this fraction by dividing by the greatest common factor. The greatest common factor of 24 and 6 is 4. Negative 24 divided by 4 is negative 6. Or rather, we divide by the greatest common factor of both of these terms. Negative 24 and 6, the greatest common factor would be 6. So negative 24 divided by 6 is negative 4. And 6 divided by 6 is 1. So we rewrite negative 4x over x. Recall, if you will, that both x's have a 1 in the exponent position. So now we apply the exponent rule that says when the bases are the same, we subtract the exponents to divide. And we get negative 4x to the 1 minus 1 equals negative 4x to the 0. The 0 exponent rule says x to the 0 power is 1, so that's negative 4 times 1, which is just negative 4, and that is a quotient term. It's written above its matching position in the dividend section and multiplied by the entire divisor. So we have negative 4 times 6x plus 1. And we distribute both terms. We have negative 4 times 6x equals negative 24x. And we have negative 4 times negative 1, which is negative 4. So we write that here, negative 24x minus 4 under its matching term of the dividend. And then we use a ruler to draw a line. And then we change both of our signs. This becomes positive, and they both cancel, leaving 0 as a remainder, and giving us the quotient of x minus 4 for our width. Okay, moving on to number 5. Jay, Taylor, Elizabeth, Lawrence, and Violet started a book club and are installing shelves for their new library. One shelf has a surface area defined by a of x equals 8x squared minus 75x plus 27 square inches. If the width of one shelf is defined by w of x equals x minus 9 inches, which function correctly defines its length? Okay, so we're talking about a shelf. So a shelf is just an elongated rectangle, kind of like this. And that's a bookshelf as seen from above. And for our books, we'll use purple. So we're given the area, and that's the area, that's the shaded region here. The surface area of the bookshelf is given by the area function a of x equals 8x squared minus 75x plus 27. What else are we given? We're given the width right here, x minus 9, that's the short side. So we're given w of x for width equals x minus 9. What we're actually trying to find here is the length. So the length is given by the length function L of x, but we don't know what it is. So we'll use the length formula L of x for length equals a of x for area divided by w of x for width. Substituting in our values into the polynomial long division form, we say 8x squared minus 75x plus 27. And we'll use our ruler to draw a long division bar. In the divisor section, we'll write the width, which is x minus 9. Now, we will make this a lighter shade of purple. So we're going to divide the first term of the dividend by the first term of the divisor, which gives 8x squared over x. 8x squared over x. There's nothing to reduce numerically, but remember, if you will, that there's a 1 in the exponent position of the x in the denominator. And so we can apply the quotient rule that says that when the bases are the same, you subtract the exponents of the variables to divide. So that's 8x to the 2 minus 1, which gives 8x to the 1, which is just 8x. And that is a quotient term. which we'll write in its matching position above the dividend, right here. And then we'll multiply it times the entire divisor. So in side work, we have 8x, open parentheses, x minus 9, close parentheses, equals, okay, we're going to distribute here. 8x times x is 8x squared. 8x times negative 9 is negative 72x. And we write that here underneath its matching terms in the dividend, 8x squared minus 72x. We draw a line, and we change both signs. This becomes negative, this becomes positive, this always cancels, this never does. Negative 75x plus 72 gives negative 3x. We bring down the next term of the dividend with its sign plus 27, and we start the process all over by dividing negative 3x by x. First term of the dividend by the first term of the divisor. So in side work, we have negative 3x divided by x. Recall, if you will, that both of these have exponents of 1, and there's nothing to reduce numerically, so we just jump to applying the quotient rule. So we have negative 3x to the 1 minus 1. When applying the quotient rule, if the bases are the same, you subtract the exponents, so you have negative 3x to the 1 minus 1, which is 0. Applying the 0 exponent rule, we say anything raised to the power of 0 is 1. So that's negative 3 times 1, which equals negative 3. Negative 3 is an quotient term, so we'll write it above its matching position in the dividend right here, and we will multiply it with its sign times the entire divisor. So we have in the side work, negative 3, open parentheses, x minus 9, close parentheses, apply the distributive property, and that equals negative 3x plus negative 3 times negative 9 is positive 27. So we have negative 3x plus 27, and we draw a line, and we change both signs. This becomes positive, this becomes negative. They both cancel out, and there's no remainder, giving us the quotient of 8x minus 3, which is the length, 8x minus 3, right here. I hope you found this tutorial helpful. If you did, please consider giving the video a like. And if you have not already, please subscribe to the channel and hit the notification bell so you're always alerted when I release new videos. Thank you.